Hey Year 9s, let's take up Assessment 2. Now this was a big assessment that involves a lot of different topics, and a lot of you found it quite difficult, and that is not surprising because I took the topics from all of the questions that you were finding difficult on the previous checkpoints. This is so that we're practicing the skills that we need to practice and not just going over the things you already know. So please don't be discouraged by your mark. Just make sure that as we're going through this, you fully understand your mistakes and you know how to do it for the next time. This is a probability question. If you like, if this is your first time through this assessment, what you can do is you can hit pause and you can try the question again and then hit play as we take it up to see how you did. Now, the thing that you need to remember about probability is that probability is always a value between 0 and 1. Notice down here the probabilities that you're given are 0.1, 0.45. It's never a probability of 5 or 10 or 20 because the highest possible probability that you can have is 1, and that's a probability that says that something is certain to happen. A 0 probability means that something is impossible that it will happen. And total probability, that is the probability of all the possible outcomes, that will add up to 1 because we were certain that one of these numbers will come up on the spinner. Okay, this is a biased spinner, so all the probabilities are not equal, so we can't say it's 1 divided by 4. We already know that the probability of spinning a 1 is 0.1, the probability of spinning a 4 is 0.45, and these two probabilities here, which we don't know, is some multiple of x. X is some value that we can find the value of knowing that this has to add up to 1. So we're going to set up an equation that is that 0.1 plus the 3x plus the 2x plus the 0.45 needs to add up to a total of 1. And then we're just going to solve this algebraically here. We've got two x terms, but that doesn't mean we have two x's. I've got 3x plus 2x together. That would make 5x. So I can group my like terms. That would be 5x plus my numbers. I can add 0.1 plus 0.45, and that's 0.55. Okay, so I've got 0.55 plus 5x equals 1. I'm trying to work out what x is for this first part of this question. So I'm trying to get x on its own. So I'll send the 0.55 to the other side. On this side it's plus, on that side it'll be minus. So 5x is equal to 1 minus 0.55. And x on its own, I need to move the 5 across. 1 minus 0.55 is 0.45. And that divided by 5 is 0.09. I saw a lot of put their answers for x as 0.11, and I'm sure that that must be people making mental mistakes and thinking 0.55 divided by 5 is 0.11, but they didn't rearrange this correctly. So x is 0.09. What's the probability of spinning a 3? Well, if you've got x wrong, you're going to get this wrong because the probability of spinning a 3 is 2 times x. So 2 times x, when x is 0.09, it's going to be 2 times 0.09, which is 0.18. So the probability of spinning a 3 is 0.18. Part C, how many times out of her 20 spins did Amy spin a 1? Okay, this is an interesting one. When you're saying what you would expect out of an experiment, you think about the probability of something happening, and 0.1 is the same thing as a tenth. I would expect to spin a 1/10 of the time. So if I'm going to spin the spinner 20 times, I would expect to get a 1/10 of 20 times. The estimated number of success is equal to the probability of success multiplied by the number of tries. So in this case, the estimated number of 1 is equal to the probability of 1s multiplied by 20, which is 1/10 times 20, which is 2. I would expect to get a 1 2 times out of 20 spins. Right, next question. Once again, if you want to try this on your own, hit pause now, give it a go, and then see how we take it up. Right, this one had a lot of problems on it as well, and I think this just goes to show that I should never give you marks. I should never be generous in that way because then you assume that you don't need to revise this, and clearly there were a lot of mistakes on this starter earlier this week. Now, to work out an estimate for the mean, it is never a guess, it is never a rounded value. It is a calculated value, but we can't be certain that it is perfectly accurate. I don't know how many people this is. It's some number between 1 and 10. That's some number between 11 and 20. And I don't know how many it is. So I have to estimate using the midpoint. So in the middle of 1 and 10, The midpoint is the sum of the two values divided by 2. I'm basically averaging these two values to find out what's in the middle. And in the case between 1 and 10 is 5.5. 1 plus 10 is 11, divided by 2 is 5.5. I do the same thing for all of these classes to find the middle of the class. 11 plus 21 is 30, 11 plus 20, is 31. Divide that by 2, that's 15.5. So I do that for each of these, and these are my midpoints. 5.5, 15.5, 25.5, 35.5, and 45.5. The problem we had on the previous starter was that there was a typo down here, and we didn't have all of these classes being even widths. But here they are all even widths. Here I did find the exact midpoint for all of these. But that doesn't give us the exact total because I'm estimating. Some of the buildings may have had more, and some of the buildings may have had less. But by using the midpoint, I'm sort of averaging out. I'm taking a guess, but an educated guess at what I can expect or estimate the total number of people there were in this building. So from there, I'm going to say if there were 5 people or 5 buildings with 5.5 people in them, the estimated total for those 5 buildings is 27.5. That's doing 5 times 5.5. Next, there were 7 buildings with between 11 and 20 people in them. We'll assume that they all had 15.5 people in them, so 7 times 15.5 is 108.5, and so on. It would really help if you're showing your working, because I can't keep all these numbers in my head. You should be writing them down. That way as well, if you have a mistake, you can send me your working and we can see what that mistake is. So keep going. 15 times 25.5, 17 times 35.5, 1 times 45.5. Those are my estimated totals for each of these classes. This is a class between 1 and 10. This is a class between 11 and 20, right? Now, to find the estimated total of number of people that were counted all together, I just need to add all of that up. So the estimated total is 1,167.5. Now, I have not rounded that. This is not a guess. You can see how I worked it out, but I don't know how accurate my working is because I didn't know exactly how many people were in any of these buildings. I had to use the midpoints. So that's what an estimate for the total means. And my estimate is exactly 1,167.5. That should go down here. Next, when we're looking for the estimated mean, we find the total value. So that's why we needed that first. And we divide that by the total frequency. Now we can add up the frequencies to find the total frequency, but we were also told in the question that there are 45 different apartment buildings in this city. So these are the 45 different apartment buildings. Add that up to check, and I hope that's right. So our total of the values was the total number of people divided by the number of apartment buildings. 5 plus 7 plus 15 plus 17 plus 1 should be the total number of people out of 45. That should give us our mean number, our average number of people per building, 25.94 recurring. Now, I could write 25.94 recurring if I knew how to type that, but I would imagine most of you would have just rounded that to the nearest 3 significant figures is what we generally round to, or to 1 decimal place, so that's 25.9. I did check your answers and I made sure that nobody put 25.944444 or 25.94. So I made sure that if you had done that, you would get the part marks for doing the correct working. Okay, let's go into the next question. Again, if you want to hit pause and try this for yourself first, please do that. We're going to take this up now though. Now this is averages and frequency tables again. We're Rajiv, and we have learned to mistrust Rajiv now, or at least think before you agree with him. Rajiv thinks the range is 4. Do you think he's right, yes or no? Now, I hope some of you aren't just being biased towards Rajiv because he's been wrong in the past, and a lot of people said no. But Rajiv is actually right. The range is 4. The range is the highest minus the lowest, so that's the highest value, not the highest frequency. We're talking about the range of numbers of phone calls. Rajiv is right for a change. The highest value minus the lowest value, 5 minus 1, is 4. So yes, he's right, and my explanation is over here. Now, a lot of people put very long worded explanations, but I was looking for some reference to the 5 and the 1, or simply the fact that there was no 0. Okay. Next question, we're looking at mixed number calculations here, and this you definitely should be writing out you're working for. I gave you the answer, so obviously using a calculator is not going to help with this. You need to show that you know how to work out this answer for yourself. First of all, as a top-heavy fraction, we need to turn the first fraction into a top-heavy fraction. 4 times 7 makes 28. So I've put here that that's 28 plus the 2 that's already over the 7. That's 30 over 7. And the second fraction, as a top-heavy fraction, I do 2 times 5, which is 10, plus the 4 that's already up there, that's 14 over 5. If you want to try that on your calculator, you can always do 30 over 7 on your calculator, and it should tell you it's 4 and 2/7. And if you do 14 over 5, it should tell you that it's 2 and 4/5. Okay, so our first two answers, the numerator is 30 for the first one, and the numerator is 14 for the second. Next, true or false, you need a common denominator before subtracting your fractions. Now I've got two top-heavy fractions. In order to subtract this, I'm not going to do 30 minus 14 because I don't have the same denominator. I do need a common denominator before I can do that. Okay, in order to get a common denominator, the next question is leading you there. The lowest common multiple of 7 and 5. What is the lowest common multiple of 7 and 5? It's 35. And that being the case, I'm going to get a common denominator of 35, which means I've multiplied the top of this fraction by 5 and the bottom of this fraction by 5, giving us the 35 down here and the 150 up here. And I multiplied the top of this fraction by 7 and the bottom of the fraction by 7. That's how I got the 35 on the bottom, and the top became negative 98. So now that I've got a common denominator, I can do the subtraction, and I get 52 over 35. So before simplifying the top-heavy answer, so this is my top-heavy fraction now, and it's 52 over 35. Then I can simplify that, and I can say how many 35s go into 52. I can fit one of them, because 2 would be too many. 2 times 35 is 70, so there's one 35 in 52. And then there's 17 left over, because to make 52, I need that full 35 plus 17 to make 52. Okay. Right. Next question, without performing the calculation, how many decimal places will the answer have? Now, we're not using a calculator for this because there's an easy way to know how many decimal places you should have. When you multiply two decimal numbers, you multiply them as if there are no decimals at all, and then your answer, you just say how many decimal places were there in the question. 1, 2, and over here, 3, 4, 5 altogether. So in my answer, there are 5 decimal places altogether. Right. Next question. Now, this question, there's a lot of controversy about it as well, so I took it off the exam because the wording of it was wrong. That was a mistake that I made. So some of you answered as if you're correcting my wording mistake, and other of you answered the best way you possibly could given this answer. So I gave you guys bonus for that. But this shouldn't be what should go on top. It should be what should go on the bottom, because my options here don't help me to find what goes on top. On the bottom. So to perform a long multiplication, to multiply this and this together, what value should go on the bottom? Should it be this value because it has fewer digits? So when I'm multiplying it through, I do 1 times this, 2 times this, 3 and 4 times this. So I got 3 lines of working. Does it make absolutely no difference? Should it be 0.0014 because that's the smaller number? Or should it be 0.0014 because it has fewer significant digits? That's your non-zero digits. And it's meant to be this one down here, because if I multiply 0.0014 by 4.21, doing the multiplication through, I would have to do 4 times 4.21 and 1 times 4.21. And I won't bother trying to multiply 0 by 4.21 because I know that'll be 0. So I only have 2 lines of working with this one on the bottom, whereas I would have 3 lines of working with this one on the bottom. So the correct answer, had we had the correct wording, would have been the 0.0014 should be on the bottom. And not just because it's smaller, but because it has fewer significant digits, fewer non-zero digits to multiply through. Right, question 7. This is a proportion problem, and again, you might want to pause this and try this working out for yourself again, and then see how we take it up. But I'm going to keep going here. It's proportioned to show that here we've got the ratio, or we've got the currency exchange for euros to yen. And here we've got a price in euros, and we can convert it to yen. Here we've got a price in yen, and we can convert it to euros. And we need to compare which to see which one is the better deal and which one is cheaper we're looking for. Okay, so how much does a French camera cost in yen? Hope we can last. How much does a French camera cost in yen? So that's this camera here. I'm showing my working by starting to set up the ratio of the currencies over here. And then I'm going to work out the French camera. That's the 85 euro camera. So that goes on the euro side. 85. I want to work out the yen side. In order to do an equivalent ratio like this, and this is something that we're going to be working on, equivalent ratios, we have to do the same thing to both sides, and it's always either multiply or divide. So I'm not going to say that I added 87 to this. I multiplied this number, or 84 to this, sorry. I multiplied by 85. So if I multiply this side by 85, I must multiply that side by 85. That's going to be 10,089.5. So in Japanese yen, I'll put the answer 10,089.50 because money is always given to 2 decimal places. Notice up here, they gave us the conversion of euros to yen, 118.70, not just 118.7. It's always 2 decimal places, even though over here, am I working, I only have 1 decimal place. Next, how much does the Japanese camera cost in euros? So again, I'll start with my euro to yen ratio, but I'm going to put the yen price of the Japanese camera on the yen side. And now I need to figure out how did I get from 118.70 down to 10,050. That's a difficult calculation. It's not as easy as how do I get from 1 to 85. That was nice and easy. It's easy to find out what to multiply 1 by to get any value. So that's going to be my first step. This is called the unitary method, getting a ratio which is a 1 to something ratio. But this time I need a ratio that is some number to 1 because I want the 1 on this side. So in order to get 1, I take this one step in between. I divide 118.7 by itself to get 1. And if I'm dividing this side by 118.7, I'm dividing that side by 118.7, which is going to be a horrible looking decimal value. So I'm just going to leave it as a fraction. 1 over 118.7. My next step, to make it nice and easy like I did above, I just had to times 1 by 85 to get 85. Here I'm going to times 1 by 10,050 to get 10,050. I need to do the same thing to both sides here though, so I'm going to times this side by 10,050 as well. That gives me 18.667. I think that was rounded, but no matter. Money is always 2 decimal places, so I'm going to round that to 2 decimal places, and that's going to be 84.67 because a 6 with a 7 after it rounds up. Right, in which country was the camera cheaper? Let's be clear about this. We want the lower price. Now in Japan, the camera cost $84.67, which is less than 85. Or in France, the camera cost $10,089.5, which is more expensive than the Japan camera. So the cheaper camera was the Japanese camera. Right, speed, distance, time. Guillermo and Mateo run a 200-meter race. Mateo runs the race in 20.5 seconds. Guillermo runs the race in an average pace of 9.75 meters per second. This question is very similar to the previous one. We're looking at 2 different measures, and they're measuring different things. Here we're measuring time, and here we're measuring speed. Hit pause if you want to try this on your own. Otherwise, let's go on and do this conversion. I want to work out the average speed that Mateo is running at. I know his time, I know his distance, let's work out his speed. Okay, so here's my working for Mateo. I know the distance is 200 meters, I know the time is 20.5 seconds. The speed is distance divided by time. That's a formula that we know. So the speed must be 200 divided by 20.5, which is 9.756 meters per second. Rounding that to 3 significant figures though, that's 3 non-zero digits. The most high place values is 9.76 meters per second. So 9.76. Read the question, make sure you're following the instructions, 3 significant figures. B, Work out how long Guillermo takes to run the race to 3 significant figures. So again, we need to round to 3 significant figures. And for Guillermo, we were given his speed, and we know that the distance was the same for both of them. So here's Guillermo's work. Guillermo, we know that the distance is 200 meters, just like Mateo, and the speed was 9.75 meters per second. We know to calculate time, that's going to be distance divided by speed. So the time that Guillermo takes would be 200 divided by 9.75. That works out to be about 20.5128. Now to 3 significant figures, that's 3 non-zero digits, non-leading or trailing 0 digits. This 0 here is significant because it's in between 2 non-zero digits. So 3 significant figures would be 2, 0, 5, with a 1 after it, does not round up. That's 20.5 seconds. And who wins the race? Now let's not get this confused. To win the race, you want to take less time, but looking at the times, it looks like they took the same amount of time. Remember that Guillermo's time was rounded though. Guillermo took a tiny bit more, right? Or you want a higher speed. Mateo's speed, 9.76, is higher than Guillermo's speed, 9.75. He travels more meters per second. So who wins the race? Mateo wins the race with the higher speed and the lower time. Next question, circumference. Now for this, you're going to need to know a couple of formulas and know how to do them on your calculator. The circumference of a circle, you can calculate either by doing 2 times pi times r, and pi is a button on your calculator. Go looking for it. It's the one where if you push that button, it should be 3.1415, and that goes on and on and on. It's a long, long, non-terminating, non-recurring decimal. Okay, so it's 2 times that number times the radius. Now a radius, we should know, here's my circle, is the measurement from the center of the circle out to the circumference of the circle. The circumference is the measurement around the circle. The other formula is pi times diameter. Now this should seem familiar to you because they look very similar, and a diameter is 2 radiuses. It's from the center out to the circumference on one direction and out to the circumference on the other direction. It's the whole way through the center of the circle. So that's 2 radiuses, which is why the formula is pi times diameter, because diameter is the same thing as 2 radiuses, or 2 radii. Right? So working this out, we are told the diameter. The diameter is 9.8 centimeters. So let's make sure we don't confuse the formulas here. I don't want to put this in instead of r. On the can of beans, that's the diameter. Okay? So I'm going to use this formula here because it's already ready to go. I'll just put the d in for the d. And I'll say that the circumference is equal to pi times diameter, which is pi times 9.8. Using your calculator, you're going to get a really long, non-terminating decimal answer. We need to round that answer to 3 significant figures. That's what they always ask for. Either 3 significant figures or 1 decimal place, or sometimes they'll say 2 decimal places, but here they're making it clear. 3 significant figures. Again, that 0 is in between 2 non-zero numbers, so it is significant. That's 3, 0, point, a 7 with an 8 after it will round up to an 8. So that's 30.8, 30.8 centimeters. Okay, money problems and percentages. Again, hit pause if you want to try this on your own. Let's start taking it up though. 2 adults and 3 children go to the cinema. A single adult ticket costs $7.95. A single child ticket costs $5.40. Work out the total cost for the family's cinema tickets. Well, I've got to pay for 2 adults and 3 children, so that's 2 times the price of an adult plus 3 times the price of a child. It's going to be 2 times 7.95 and 3 times 5.40. Working that out, that's 15.9 plus 16.2, which is 32.1. Again, this is money, so I always give to 2 decimal places, so I need to put a 0 on there. That's $32.10, not $32.01. Okay, the special family pass costs $25 for the whole family. Work out the percentage the family would have saved if they bought the family pass instead. Their savings would have been the regular price minus the sale price, the difference between the two. So we've already worked out the regular price. We know what the sale price is. It's 25. We're going to work out the savings. However, we're asked to work out the percent savings. Percent savings is the amount that we saved over the original price. It's always over the original price. Just like percent change, percent increase, percent decrease, percent profit, percent loss. It's always over the original value. Okay, so we're going to do 32.1 minus the 25 that we would have had to pay with this sale price over the 32.1. And to turn that into a percentage, we always have to times our fraction by 100. So that's going to be 7.1. We would have saved $7.10 out of $32.10. That fraction, to turn it into a percentage, top divided by bottom, and multiply by 100. So that's a long decimal number. I'll have to round that, but that's 0.221838 times 100. That's approximately 22.1838%. And if I want to round that, because it's a very long percentage to write, I should generally round to 3 significant figures or 1 decimal place. So that's going to be 22.1 with an 8 after it. It's going to round up 22.2%. Question 11, sharing by ratios. Again, ratios, a topic that I know that we need to practice and we will be practicing a lot. Sarah and Tamara share 60 sweets in a proportion of their ages. Sarah is 18 years old and she gets 36 sweets. How many sweets does Tamara get? If there's 60 sweets in total and Sarah got 36 of them, Tamara will get the rest. So 60 minus the 36 is 24 sweets for Tamara. Next, how old is Tamara? Well, we're talking about ratios here. And we said that the ratio of their ages is the same as the ratio of the sweets. So I'm going to go ahead and write the ratio of Sarah and Tamara's ages, because I was given Sarah's age here first, 18. I don't know Tamara's age though, that's what I'm trying to work out. Then I'll write the ratio of the sweets, because it should be an equivalent ratio to their ages. They say that they're sharing the sweets by proportion of their ages. And Sarah has 36 sweets. And we just finished working out that Tamara has 24 sweets. So now, to work out how old Tamara is, we have to look at the relationship between these ratios. I can see that 36 is twice 18. Or to get from 36 to 18, I need to divide by 2. Just like we did before with our ratios for currency, we have to do the same thing to the other side. So if I'm going to divide this side by 2, I'm going to divide that side by 2. So 24 divided by 2 is 12. Tamara must be 12 years old. And that makes sense that Sarah was older, she got more sweets. Tamara was younger, she got less sweets. Tamara got 12 sweets. Or is 12 years old, sorry. Right, sharing, but no, this shouldn't be sharing by ratios. This is wrong. This should be composite shapes and areas of composite shapes. Okay, so working out the area of this shape. First of all, you have to notice that there are some things missing. And drawing a sketch of this might help you to figure out what is missing. I don't know what this length across the top is, and as I split this rectangle down here, I would need to know what's across the top, because to find the area of a rectangle, I need to do length times width. Okay, so this little bit across the top here, it's got to be whatever I need to add to 3 to make a total of 7. Or 7, if I cut off that 3, what's left? 7 minus 3, this is 4 centimeters across here. Okay? And you can see I've cut something off over here. This is 5. How much is left in order to make 9 altogether? Or 9 take away 5 is 4. 9 minus 5 is 4, so this side length here is 4. Okay? Now working out the area of a composite shape, we're going to work out areas of each of these smaller parts and add them together. So total area is equal to area A plus area B, where this is my area A and this is my area B. Area A, I do length times width. That is 9 times the 4, which is 36. And area B, I do length times width, which is 3 times the 4, which is 12. But showing my working nice and clearly over here, I'm going to show. To find area A, I did 9 times 4. To find area B, I did 3 times 4. And that together is 36 plus 12, which is 48 centimeters squared, because everything here was measured in centimeters, and this is an area squarea, 48 centimeters squared.